Okay, in this video we are going to study sign of a logarithmic function. Firstly, for the logarithmic function, we have to be careful about the a value here. Logarithm base a, it should be logarithm base a, logarithm base a x, it's going to be if it is greater than 1 and if it is between 0 and 1. Here this case is a is between 0 and 1 case. Here this is the a is greater than 1 case. And when, as you understand, when a is between 0 and 1, function is decreasing, it's going to be. So when you increase the value from 2 to 4, when you increase the value, you're going to understand that the function is decreasing, so it means that y value is decreasing. And between a is greater than 1, function is always increasing, so when you increase the value 2 and 4, here the value, y value also, it's going to increase. And we need to understand a is greater than 1 or a is greater than 1 or a is between 0 and 1. So we are going to try to understand this one. Here there are two values. For example 26, we have two values. One of them is the base is equal to 1 over 2. In the second one, the base is equal to 10. So this is between 0 and 1 case. This is between greater than 1 case. And here, when it is between 0 and 1, it's going to be in this one. And state the numbers are positive or negative means greater than 0, or smaller than 0, we have to find. And why it is 0? Because logarithm a1, actually logarithm a1 value is equal to 0. So when we are comparing the values in logarithm, we are comparing with a1. And here, positive or negative, when we are comparing, we should compare with a1. Here, the value it's going to be for this one. We are going to compare logarithm base 1 over 2, 0.9, or logarithm base a, this a is equal to 1 over 2, 1. Which one is bigger? This is 0, so if it is greater than, this is positive. If it is smaller than, this is negative. And we should remember this one. 0.9 and 1, 1 is bigger than 0.9. This is decreasing function. And if 0.9 is smaller, it means that it is bigger. In the decreasing function, when the x value, here what is written here, these are the x values. When the x value is smaller, the function is bigger, opposite. For the second one, logarithm base 10, 0.15, and logarithm base 10, 1. Which value is bigger, 0.15 or 1? 1 is bigger, so it means that this is bigger. So if this value is equal to 0, logarithm base 1 over 2, 0.9 is greater than 0, and logarithm base 10, 0.15 is smaller than 0, is going to be. So the first one is, this one is greater than 0, this one is smaller than 0, it's going to be. Okay. Yes, what about inverse of logarithmic function? Here, exponential function, a to the power of x, when a is greater than 1 here, and here a is also, it's written here, a is greater than 1, a is between 0 and 1, the exponential function, it is in this form. Like this is 2 to the power of x, and this is 1 over 2 to the power of x. You may think like that. And if you remember, I tried to explain like this. Y to the power of x, with respect to y to the power of x, it's going to be symmetric. When it's increasing, getting closer to y to the power of x, it should get closer. Or when you are away from when the function away from the y is equal to x line, here it should be also away. And we can understand like this. When you choose one point, from this point, when you draw the perpendicular line to the y is equal to x line, this, and if you continue to that one, this, when it is intersecting with the y is equal to a to the power of x function, here the distance here, it should be same. Or when you choose the point here, you may choose the perpendicular point here, then here when you continue to this side, this distance and this distance, it's going to be same. And here if you check, you are going to see this distance and this distance, they are equal to each other. So we are deciding with respect to, on the graph, with respect to this one. Okay, how to find the inverse of the 2 to the power of x or 3 to the power of x plus 1? We said y is equal to, we know this one, y is equal to 2 to the power of x. Normally this is the exponential form of the function. And if you want to make this one logarithmic, you should send this one as a logarithmic base and you should leave the x alone. When the x is alone, the function that you found, it's going to be inverse function. So it should be like this. X 2 to the power of x is equal to y. X is equal to logarithm base 2y. The function, when x is alone, the function that you find, it's equal to f inverse y. So f inverse x is going to be equal to logarithm base 2 x. Okay, what about the second one? Y is equal to 3 to the power of x plus 1. 3 to the power of x plus 1 is equal to y, we can write like that. Then when you get the logarithm of both sides, it should be like this, logarithm base 3 to the power of x plus 1, you can do like this also, and logarithm base 3 y. I got the logarithm of both sides, the power is x plus 1 here, it's going to be in front of the logarithm here, and it's going to be equal to x plus 1 is times logarithm x plus logarithm 3 is going to be x plus 1, it should be in bracket, it's going to be equal to logarithm base 3y, and this is equal to 1, so x plus 1 is equal to logarithm base 3y is going to be, and if you send the term to this side here, I mean the 1 to the other side, x is equal to logarithm base 3y minus 1 it's going to be. So when the x is alone, the function that you found, it's going to be inverse function. X is equal to logarithm base 3, f inverse x is equal to, f inverse x is equal to logarithm base 3x minus 1. Okay. How to find the inverse of logarithmic function? Of course, we are going to find the here inverse of the logarithmic function like this. Y is equal to 1 minus logarithm base 2x minus 1. So firstly, logarithmic function we can send to other side, and it will be like this. This one will come to this side and y will come to other side, and it will be like this. Logarithm base 2x minus 1 is equal to 1 minus y. Then to leave x alone, I need to do inverse operation of logarithm here. X minus 1 is equal to 2 to the power of 1 minus y, and x is equal to 2 to the power of 1 minus y plus 1. When x is alone, the function that you are finding, it's going to be the inverse function. So f inverse x 2 to the power of 1 minus x plus 1 is going to be. Here, for the second one, ln x plus 2 we have to be careful about only the sign of the function here, because actually the base of the function ln x plus 2 means logarithm base ex plus 2. If this value is equal to y, it means that x plus 2 is equal to e to the power of y, and x is equal to e to the power of y minus 2 is going to be. When you get x is alone, the function that you find on the other side, it is f inverse. So f inverse x is going to be equal to e to the power of y minus 2. Minus 2, it is not power, it should be here, sorry.